My name is Prasad Kadambi, and I want to welcome everybody to this webinar of the American Nuclear Society's Risk-Informed, Performance-Based Principles and Policy Committee. We call it RP3C. I am the chair of RP3C. The purpose of RP3C is to help modernize ANS standards. Modernization has come to mean that risk-informed and performance-based methods are employed to overcome the difficulties that we all know about with purely deterministic and prescriptive methods. We've been calling these methods RIPB approaches, and RIPB approaches have been recognized in the Nuclear Energy Innovation and Modernization Act, and therefore it's in statute. There is a lot of guidance available on RIPB approaches, but most people have not had reason to become familiar with the guidance because the conventional approaches still dominate most things that we do, including standards development. Right now, I think ANS can be considered as a knowledge center for information regarding RIPB approaches. RP3C initiated these community of practice webinars on RIPB to enable practitioners of these methods to share their knowledge and experience. We have scheduled these for the last Friday of every month. Today, we will hear from Patrick White, who is going to speak on behalf of the Nuclear Innovation Alliance, which is a non-governmental organization. I want to recognize and I want to thank Patrick for coming forward to make this presentation, because we have not heard from a non-government organization, NGOs, and there are many of them who are very active in advanced reactors. And so I do hope that it'll all help us understand, what is the perspective from this community. So Patrick, would you please introduce yourself and go ahead?
Great. Thank you so much, Prasad. Very excited to be here and happy to speak with the group today. So my name is Patrick White. I'm a project manager with the Nuclear Innovation Alliance. You might be wondering who the Nuclear Innovation Alliance is. Well, described as a think and do tank focused on creating the conditions for success for advanced nuclear energy as a climate solution. And so really what our organization does is works to identify barriers, perform analysis, engage with different stakeholders, policymakers, and really kind of figure out how we can nurture innovation and entrepreneurship throughout kind of the nuclear ecosystem. What that all kind of really means is that there are a lot of barriers to the deployment of advanced nuclear energy as a climate solution. Our organization is primarily funded through private climate philanthropy, and what we're really interested in is how can we make nuclear part of the climate solution. And so what we do is work to really kind of connect stakeholders and say, how do we identify the barriers and how do we come up with solutions for those? We don't work with any of the developers in particular, but we essentially work with them as a community, identifying kind of what are problems that they're seeing what kind of problems are common between different developers, different technology enthusiasts, and then say, how can we try to come up with solutions for those? We do this through reports, through webinars, through different technical analysis. Some of these include things like Vision, where we outlined a potential pathway to really see advanced nuclear play a role in deep decarbonization, or things like our primer, which is more of an educational tool to kind of reach out to policymakers and say, what are the advanced nuclear technologies that are out there, and what are potential opportunities for them as we think about deep decarbonization. What really kind of differentiates Nuclear Innovation Alliance from other kind of NGOs or think tanks in the space is really kind of our focus purely on advanced nuclear energy, on nuclear as a climate solution, and on technical analysis. A lot of other groups, and these are groups that we work with regularly in the space, may be focused on a multitude of issues related to clean energy, or may look at them from a slightly partisan angle. Some groups may look at kind of focusing on solutions to the right of the political center, to the left of the political center. NIA is really kind of focused on what are the technical solutions that we need to do. And one of our major focus areas is regulatory modernization. Really kind of saying, what are the potential barriers to the deployment of advanced nuclear energy when it comes to regulation, and how can we try to update that regulatory system to overcome those barriers? One thing I'll just add, a little bit about my personal background. Nuclear engineer by training. I did my bachelor's and master's degree in mechanical engineering at Carnegie Mellon University. I then worked for several years in the commercial nuclear industry, working for NPR Associates out of Alexandria, Virginia. Then went to MIT in 2015 to do my master's and my PhD in nuclear science and engineering. My master's work was on the development of regulation for advanced fission systems and identifying barriers to licensing. I was a co-author on the 2018 MIT report on the future of nuclear energy in a carbon-constrained world, leading the report section on regulation and licensing. And my doctoral work was on looking at the licensing and safety analysis of commercial fusion energy and trying to develop kind of a technology-inclusive framework for that. I joined NIA in 2021 and have been working to lead their technical and regulatory program since. And so with that, I'll jump a little bit into the actual content of the presentation. So from a very high level, NIA is really interested in developing modern and effective regulatory frameworks because it's really critical to the successful deployment of advanced nuclear energy. Effective nuclear regulation is going to help make sure that the nuclear technology that we're designing and developing is going to be economically competitive and can be safely operated. And simultaneously, we're really interested in effective nuclear regulation because it's critical to timely deployment. If we have a regulatory process that takes decades, well, we're not going to see the deployment we need to really hit our clean energy goals by 2050. And finally, kind of tying this all together is the idea of societal acceptance. If we have an effective nuclear regulator, we can build public trust and hopefully build consensus around the technology, rather than having kind of the traditional paradigm of needing to fight communities and fight people for this deployment of nuclear energy. We want to really see it as technology that's pulled in and wanted by society and not something that's pushed on society. And so when we talk about kind of a modern and effective nuclear regulator, NIA really kind of works to address a lot of the factors that contribute to the predictability and the timeliness of advanced reactor licensing. One of the things that we really believe is that it's important to recognize all the different factors that affect regulation and not just think of this as a problem for the regulator. So when we think about kind of the Nuclear Regulatory Commission, it's how they're working with existing regulatory frameworks and requirements for licensing advanced reactors, how they're working to develop new regulatory frameworks such as 10 CFR Part 53, and then even kind of issues that are a little bit harder to quantify, such as what effects NRC management and staff culture may have on the success or challenges in the regulatory process, and how the NRC commissioners themselves are actually providing leadership on policy questions. All of those can be critical to the predictability and timeliness of advanced reactor licensing. Simultaneously, though, there are issues that advanced reactor applicants and folks in the industry and otherwise interested in nuclear energy need to be working on as well. What are the actual strategies that advanced reactor applicants are using for licensing? Are they applying best practices for preparing their licensing applications, for performing their analyses? And how are they engaging with members of the public to really ensure that there is consensus around deployment of nuclear energy? And really all of this is under the guise of Congress, who's providing both legislative oversight and legislative direction for these activities. And so when we think about advanced reactor licensing, it's really considering how all these different pieces work together. So NIA has been working to improve and develop both near-term and long-term licensing frameworks for advanced reactors. In terms of near-term, we really think it's critical to recognize that we have to get 10 CFR Part 50 and Part 52 to work correctly. If we can't kind of effectively and efficiently use the existing licensing processes for these first-of-a-kind reactors that are essentially coming through the regulatory process, we're not likely to see the second, third, and fourth kinds. So we really need to make sure that we have an effective regulatory framework today. We also need to kind of look forward to the future and say, if we're really interested in kind of mass deployment and wide-scale deployment of advanced nuclear energy, we need to make sure that we have effective regulatory rules that make sense for advanced reactors and enable deployment at scale. So that's really looking at how can we try to inform NRC rulemaking on these kind of future licensing processes and make sure that they're compatible with the frameworks that we think we need to see in the future. And really all of this is kind of underpinned by cross-cutting regulatory reform, thinking about how we can have more risk-informed performance-based regulations that we think we will ultimately lead to better designs and more effective licensing, and how we can try to promote more effective and efficient reviews by NRC staff. So why is NIA actually interested in this? Well, NIA has actually historically advocated for the use of technology-inclusive and risk-informed performance-based frameworks for the licensing of advanced reactors. Back in April 2016, we published a report, Strategies for Advanced Reactor Licensing, that even at that time was kind of aligning with some of the discussion in the field that was saying that the NRC really needs to think about how to develop and implement a technology-inclusive licensing and regulatory framework for advanced reactors based on risk-informed and performance-based principles. At that time, NI was advocating that a technical team should really start kind of developing this rule with the idea that we could have something in place by 2025 to support advanced reactor licensing. Well, we ended up getting the date right in terms of having a goal of 2025 for a Part 53 regulatory framework, but we're not necessarily sure there's been enough work that's gone into it to make sure that we have a framework that actually meets the needs of industry and will kind of help ensure that we're having the safe, effective licensing of advanced nuclear technology. I don't think I need to tell everyone that there has been some concern around the development of the Part 53 regulatory process, and that's not necessarily producing a rule that's matching essentially what industry needs and how to make sure it's something that's going to be socially acceptable. So NIA has been working to kind of rethink Part 53 and engaging with kind of a wide variety of stakeholders to build consensus on a path forward. This includes participating in public meetings, coordinating with other NGOs that are really advocating in this space, working with what we call our Industry Innovation Leadership Council, so that's engaging directly with reactor developers, and then learning about insights from different industry groups such as the Nuclear Energy Institute, NEI, individual discussions with developers, and even engaging with NRC staff and leadership. Really, the idea is trying to kind of build consensus around this topic and understand that that's how we're going to have the best path forward on advanced reactor licensing. So when Prasad kind of asks, what's the role of NGOs in this space? One of the ways I really think it kind of comes across is it's the opportunity to provide kind of new thoughts, new direction, or validation for different perspectives kind of within the public sphere of the NRC. You can imagine if you're an advanced reactor developer, your focus necessarily has to be on how to support the development and licensing of your technology. It's great to be able to spend time on kind of higher level projects or think about the regulatory framework more broadly, but there are specific things that need to be done to get your technology to market. Groups like NIA and other kind of NGOs can come into this space, perform independent technical analysis, and either help kind of provide new thoughts and new pathways for licensing and regulation, or help kind of support and provide independent validation for claims that are being made. So on the Part 53 regulatory process, NIA has been kind of actively involved with the NRC throughout the preliminary rule development process. The figure on the right here kind of shows where we've been on the Part 53 regulatory process and where we're looking at moving going forward. So since about early 2021, I think early to mid 2020, the NRC staff was engaging with members of the public and with different stakeholders to try to determine what needed to be in a potential Part 53 rule. They then have received public feedback up through September of this year, and then are now kind of preparing a final rule that's going to be submitted to the nuclear regulatory, the actual commissioners themselves for their kind of review. And then if it's approved, it would kind of move through the rest of the formal rulemaking process for publication in July 2025. And our NIA has been starting to engage kind of throughout this process, both providing kind of preliminary high-level comments with other NGOs back in July of 2021, or even starting to provide kind of more detailed comments of how we imagine the rule could be changed to really kind of meet the needs of advanced reactor developers. So we provided detailed comments in November 2021 to the commission, and then kind of based on those, we're invited to actually participate in a commissioner briefing on Part 53, and then an NGO public meeting on Part 53 in February 2022. The idea here was really just trying to kind of provide more perspectives and more input to the staff so they start to understand kind of what the overall impact of this is. The thought is really that if you can have a bunch of people giving really, really good ideas and a bunch of voices really talking about why this is important, hopefully kind of builds that consensus that staff understands that there is a potentially different way to do this and have a more effective rule. And I submitted our final set of comments at the end of the public comment deadline in August 2022, where we really kind of highlighted the need to make sure that we do have an effective rule moving forward. So what does this effective rule actually look like? What are we interested in? Well, NIA has really been kind of advocating for a rethink of the Part 53 regulatory framework towards more of a performance-based, technology-inclusive framework. Right now, for anyone that's kind of been following the process, we've essentially ended up with two main pathways proposed by the NRC staff. The first pathway, known as Framework Alpha or Framework A, basically outlines a very LMP-like process. So if anyone's familiar with the Licensing Modernization Program, LMP, or project, sorry, I always forget that last word, a very LMP-like process where it thinks about using PRA in a leading manner, and then the staff leveraged a lot of existing text from Part 50 and Part 52 to kind of create a bit of a hybrid process for the licensing of advanced reactors. It was criticized that this process, while potentially being technology neutral, wasn't technology inclusive. It had a very direct use for PRA and didn't necessarily allow risk insights in other ways. Kind of in response, the staff went ahead and created Framework Bravo or Framework B. That was much more of a deterministic methodology. Again, leveraging a lot of the regulatory requirements from 10 CFR Part 50 and Part 52, instead implementing kind of a new process they described as ARI, which is the alternative evaluation of risk insights, which is kind of a pseudo-deterministic way to provide very high-level risk insights for power plants. Really, the problem that we saw here was that this ends up being a fairly inflexible model. You essentially end up with two pathways, but we're still in the exact same problem that we have for the existing regulatory framework, which is that it's an either or and not a way for applicants to actually come forward and say, what is their safety case and how do they see themselves meeting a higher level set of performance-based requirements. So really, while the NRC is kind of continuing the stakeholder discussion, we're really trying to ensure that this Part 53 framework that we see is something that's going to be both efficient and effective for all advanced reactor developers. Now, what does that actually really mean? What are kind of the cases that we're looking at? One of the best examples I think I can give is trying to look at what it would take to license two different reactor technologies that should both technically be covered by a Part 53 regulatory framework. In principle, we should be able to license an AP1000, a Westinghouse AP1000, and a Westinghouse Da Vinci reactor under this Part 53 regulatory framework if it is truly kind of a technology inclusive and encompassing regulatory framework. One of the challenges is that these reactors are incredibly different. Both in size, you're talking 3 orders of magnitude in terms of the size difference, and even in the kind of their fundamental design. One's going to be a water-cooled, large pressurized light water reactor versus a micro heat pipe cooled reactor. And so when we think about the different kind of regulatory paradigms that these things are going to be licensed with, it's trying to come up with how we can have a uniform set of rules that will effectively and efficiently apply to both sets. These include parts of the regulatory paradigm, like what are the regulatory requirements? What are the analysis methods that are being used? What types of regulatory assumptions are being used for their analysis and evaluation? What is the role of risk assessments? What types of organizational or programs or operational requirements might you have? Are there going to be requirements on equipment qualification, trying to think about kind of long-term operation of these facilities? And what are requirements on reactor siting? These are going to differ significantly, even at a very first pass for these two different technologies. And the question is, how do we define an effective rule that really matches both of these? So getting to the actual kind of policy challenge that NI has encountered and that we're kind of working to overcome with other folks in the space is really this idea of how do we try to overcome the kind of perceived trade-off between regulatory predictability and regulatory flexibility when it comes to the implementation of technology-inclusive, risk-informed, performance-based regulations. So I'm a big history buff, so when I like to think about kind of nuclear reactor regulation, I really think of it as kind of an evolutionary process. If we start back in the early days of the Atomic Energy Commission, the AEC, we had very much an expert review-based model. Applications were being submitted for a wide range of technology, and the AEC's early licensing staff would review them essentially on a one-by-one kind of case-by-case basis. And the idea of this process was that given kind of the limited information about the operation of commercial nuclear technology, uncertainty around design, and in many cases, uncertainty around physics, this was the most effective way to kind of license a large number of very, very different technologies. One of the challenges that was really cited early on by developers and by regulators as well was the idea that there was a low level of predictability. They weren't sure what things were being asked, and they weren't sure what was being expected of them when they submit licensing applications. They really wanted consistency, especially as they started to kind of mature the field. They wanted to know that if you submit an application that looks a certain way, you will receive an approval. And so over time, as we saw kind of a maturation of light water reactor technology, and we saw a convergence kind of on large light water reactor technology, we started to see specificity being introduced into the regulatory process. Starting early on with things like siting criteria, the general design criteria. These became kind of standard ways to think about how to license a technology, but then also start to lock in a little bit of the flexibility. Design-based evaluations, probabilistic evaluations, these became standard for light water reactors and became something that was expected. But the problem is it's starting to set a very specific set of requirements for the operation of the technology. Ultimately, when we start getting to operational safety and beyond design-based evaluations, again, this becomes a more and more predictable process. It's clear what the regulator wants. It's clear what the standards are. But the problem is it's oftentimes restricting the methods and design choices that can be used. Now, one thing that will often be countered is that there is an existing licensing exemption process And it kind of exemplifies kind of this idea of regulatory predictability versus regulatory trade-offs. So 10 CFR 50.12 basically provides for exemptions to specific regulatory requirements as you move through the application process. And so an example of this is, and not to pick on anyone that likes Holtec, Holtec for their SMR 160 was pursuing a set of exemptions to the loss of coolant accidents or the local requirements for their new reactor design, kind of based on the idea that they were integrating in a certain way the reactor vessel and the steam generator, and that there wasn't essentially a large break LOCA possibility. They worked on this process for the better part of a year and a half before they ultimately decided to kind of stop the review of a topical report that would have essentially provided them this type of exemption. And one of the challenges I think this kind of exemplifies is that they tried to get some flexibility by getting an exemption, but it definitely lowered the regulatory predictability. The burden of proof for the exemption can be highly uncertain, and significant effort can be expended without necessarily a clear pathway to a final regulatory decision. So right now, the advanced reactor developers are starting to work through the Part 50 and Part 52 process for their advanced reactor designs, and are having to work a lot on these exemptions to make sure that there is a clear path forward on licensing. The question ends up being, how can we try to create a more flexible licensing process that potentially enables the licensing of advanced reactor technologies without the kind of loss of predictability that we're interested in? And so this really gets the idea of, I think there might be a phone ringing in the background if someone can check that. And so really this gets us the idea of how can we think about Part 53 and regulatory frameworks, and how does that necessarily tie into the implementation of risk-informed and performance-based regulation? And one thing that we've encountered in a lot of our discussions as we want to try, as NIA has started to push for kind of a larger emphasis on this TI RIPB regulation, is that many stakeholders can be wary of highly flexible regulation due to the perceived predictability and review challenges. And this really comes kind of across the spectrum from both the applicant side and the regulator side. On the applicant side, there might be questions of how do you actually develop a design basis if it's not clear exactly what's going to be expected? How do you develop a licensing basis? What is the regulator going to be looking at if we just have high-level performance requirements? Simultaneously, on the regulator side, how do you actually assess applications, and how do you ensure consistency? And there's this perception that essentially poor predictability will increase the licensing risk for both the applicant and the regulator. And so as we kind of look towards the development of new regulatory frameworks, how do you start to overcome this? Kind of within our work and within our discussions, we really think that there's a way to introduce regulatory predictability using a variety of different strategies. Now, with the kind of our work, we divided it into 4 major bins. How can you introduce predictability through design requirements, through methodology requirements, through program requirements, and through process requirements? So if we think about the first, an example of a design requirement might be a way of trying to introduce predictability to regulation by saying things like reactor designs must have emergency core cooling systems. It becomes very clear that this is a strong design-based requirement that an applicant can determine whether or not they meet just simply by looking at their design and incorporating that into their design and their licensing process. You can also have regulatory predictability through things like methods. Another example of this might be the idea of probabilistic risk assessments in 10 CFR 5247, the idea that plants have to have this type of analysis, and that will then make it clear as they move through the regulatory process, yes, we can leverage those insights from that method, and that it aligns with what the regulator is expecting to see. We can also have regulatory predictability introduced through programs. So an example of this that's come up in the 10 CFR Part 53 development process has been the idea of facility safety programs in the current draft 10 CFR 53.890. And this is the idea that under kind of the Part 53 regulatory framework, there'd be a mandatory set of facility safety programs that would then kind of help ensure the continued safe operation of a nuclear power plant. You can see, though, all of these have some limitations. If you have regulatory predictability introduced by design, well, that design requirement isn't actually technology inclusive. That's going to be something that's going to be very difficult to enforce, or then is going to have to kind of go back to this exemption process, introducing inherent unpredictability. With methodologies, while I think there is a lot of consensus on using different methodologies to try to design and evaluate reactors for licensing purposes, not all designs and not all methods might be created equal or might be applicable. The idea of doing a level 3 PRA on an incredibly small microreactor and performing the work to actually perform a set of design basis analysis might not necessarily be the easiest pathway, at least on kind of a licensing framework, when you could potentially use things like a maximum hypothetical accident or other types of worst case bounding accidents to actually show that you meet regulatory requirements. While it's still something that the designer might want to do as part of their process to ensure kind of adequate design and safe operation, it might not be something that they want to have a regulatory requirement on because it just represents essentially additional regulatory burden. And again, with programs, that's something where, is this a program that's actually universal to all the different reactors that we're looking at under Part 53? Or is this something where it becomes a little bit more facility, maybe operational mode characteristic specific? One really good example of this moving forward is starting to think about the role of different sizes of reactors. What are going to be the operational and safety characteristics of a micro reactor versus a large reactor? A reactor that is 1 megawatt is probably not going to have similar staffing requirements as a reactor that's 1,000 megawatts. And how can these be kind of incorporated into the regulatory process? So NIA really comes down to this idea of how can we try to ensure kind of regulatory predictability through process? And in our mind, that really comes down to this idea of how can we try to have evaluation against technology inclusive, risk informed, and performance based requirements that allow for kind of a consistent regulatory treatment of different technologies, while also simultaneously giving us the flexibility that we need to license this wide variety. So in our mind, the flexibility and predictability of regulatory frameworks can be developed kind of on a case-by-case basis using these risk-informed requirements. So when we talk about it, we really say everything kind of drives out from this process, that an applicant should be demonstrating compliance with a consistent set of technology-inclusive and risk-informed performance-based licensing requirements. What are we actually interested in as a regulator to ensure that this plant is going to be operating safely? What are kind of the wide variety of radiological or other types of safety requirements that we might be interested in? And then from that, we're going to have still kind of underlying design, methodological, or programmatic requirements that could be used to help kind of demonstrate or ensure compliance with these high-level requirements. This starts to be somewhat similar to some of the ways we think about system engineering approaches. But within a regulatory framework, NIA feels that we might be able to use kind of these optional strategies that would provide known methods or acceptable methods for demonstrating compliance with these licensing requirements. You're not required to use these, but they're things that have already been laid out, but it's very clear that these are clearly optional. The goal is really, how is the applicant demonstrating compliance with these high-level consistent safety requirements? The challenge that we then reach is how to start to define these technology-inclusive and risk-informed performance-based requirements that don't actually prescribe things like design, methods, or programs. So thrown up here on the left, just a traditional way of thinking about a frequency consequence or probability dose chart, something that probably most people on this call are familiar with. And it's interesting thinking about how the different types of regulatory requirements that we would have might sit on a chart like this and what things are missing. So I think when we talk about kind of performance-based requirements, the idea of normal operation performance-based requirements are fairly straightforward. How do you demonstrate that your reactor isn't violating effluent limits or dose exposure limits for workers or members of the public, or other types of kind of normal operational limits, like those that we see in 10 CFR Part 20? That's fairly straightforward. They seem fairly high level and don't necessarily prescribe design methods or programs. For off-normal operation, we might think about some of the dose limits that are described in 10 CFR Part 100, such as a 25 rem offsite dose limit for members of the public during any type of accident. Again, we can kind of see a dotted red line of saying, yep, there becomes a very clear upper limit. Or maybe for some designs, they're interested in a 1 rem limit if we want to talk about offsite evacuation requirements as being something that's being self-imposed. We can then talk about other kind of requirements such as security requirements and how to have performance-based security requirements like we're seeing in some of the revisions to 10 CFR Part 73. Again, these are all methods that don't necessarily prescribe design, or these are all requirements that don't prescribe design methods or programs, but can be met by any reactor technology. The question would be, how does that applicant actually want to demonstrate it? The real challenge here is how we think about other kind of performance-based or risk-informed requirements. One thing that's come up during the Part 53 regulatory framework discussions are the roles of things like quantitative health objectives, or maybe other surrogate risk objectives that we've developed, like core damage frequency. I think we can all argue that there is some challenge related to quantifying and deciding the cumulative hazards of commercial nuclear power plant operation. You could have a facility that's worst case accident is below a regulatory cutoff, but there's a big difference between having an accident that is going to occur with incredibly high frequency right below that regulatory cutoff versus accidents that are going to be very low next to that regulatory cutoff. what's essentially the cumulative risk impact on a community or on society from the operation of that plant. And so the idea is that there needs to be some kind of risk-informed discussion here, but it's not really clear necessarily what is a method that or a requirement that we can use that doesn't necessarily start to pre-describe design methods or programs. A really good example of this, when this kind of criticism of the use of the QHOs came up during a commission briefing on 10 CFR Part 3, Commissioner Barron's question to the panel was, if not QHOs, then what? And that's a really hard question to ask, how we try to overcome that. And I think that's something that we're still kind of working through as we try to figure out how we try to implement these rules and regulation. So really, there's a need to work with NRC stakeholders and policymakers to define these technology inclusive and risk-informed performance-based requirements for advanced reactors. There's first thinking about how we can have alignment and guidance for use of these licensing methods under the existing regulatory frameworks, really recognizing the potential benefits and impacts as we talk about licensing under 10 CFR Part 50 and Part 52. We then can also talk about how do we come up with essentially a robust set of requirements and frameworks or new requirements that we can think about for new regulations. How can we try to leverage some of these best practices and insights to create a set of comprehensive requirements? And then finally, kind of after we have this firm technical basis, how can we fully implement these in new regulatory frameworks? I think the idea is they've described it as a once-in-a-generation opportunity to create a new regulatory framework for advanced reactors. How can we make sure this aligns with some of the best practices and insights that we have from operations? So from NIA's perspective, we really think that this Part 53 regulatory framework can be reimagined to facilitate both evolutionary and more revolutionary approaches to regulations. You can imagine if you start with a set of uniform performance-based requirements, if you want, you can go down the evolutionary pathway of what we've seen for years. You can leverage the existing processes in Part 50, Part 52, things like LMP, and really kind of make small incremental improvements to those processes to ensure for the licensing year design. That becomes consistent and it's predictable. You have some insights on kind of how these processes are going to work based on experience. Simultaneously, if you're a reactor developer or a technology company that's interested in taking a very different approach to licensing based on kind of what your specific technology is and what specific characteristics are, maybe there's an opportunity for you to take new pathways and essentially establish precedent as you work with the regulator to demonstrate your safety case. Whether it's working with the regulator to have development of new regulatory guidance, approval of topical reports for new methods, working with the commission to actually have new policy decisions that enable your technology, or maybe the establishment of new regulatory precedent. It essentially opens up a much wider set of potential regulatory pathways than we currently see under the Part 53 rule. But again, this kind of provides the flexibility that we want, but also the predictability for the regulation. And it's all really underlined by the set of consistent regulatory requirements, so we know we have consistent licensing. So I'll just kind of conclude by starting to say, really, when we think about technology inclusive and regulatory or risk-informed performance-based regulatory requirements, we really need to think about how these processes interact between rules, guidance, and consensus codes. In NIA's proposal, we really see an opportunity to have kind of a clear purpose statement, performance requirements, how to define self-consistent project-specific performance requirements, what makes sense for your technology, and how do you demonstrate compliance with larger regulatory rules. And then really, how do you develop a safety case basis that demonstrates it, with the idea that there are optional prescriptive methods similar to the Framework Alpha and Framework Bravo that we see under the existing process, but ultimately it's up to the applicant to decide. And all of these processes would ultimately be supported by things like application-specific regulatory decisions or regulatory guidance and approvals. So it creates kind of a more robust framework. And then this is just kind of to kick off some of the discussion. One of the things that we're really interested in is making sure that we have both kind of continuing ongoing technical and policy engagement to the successful implementation of these technology inclusive and risk-informed performance-based rules for advanced reactors. It's not just the developers working with the NRC. There are a lot more stakeholders in the process, whether it's nuclear industry groups like NEI, public interest groups like ourselves, independent technical experts like the folks on this committee, advanced reactor developers, and there's a lot of overlap between a lot of these. Or how do we work with NRC staff and management to really kind of say, these are things that should be incorporated in the rule, and here's why they're technically robust. And even working with the NRC Commission to say, these are things that you should really be driving the agency for, that really helps you fulfill your regulatory mission, but also gets us to enable the deployment of technology. And again, at the end of the day, Congress oversees all of this. And so if you're not necessarily seeing the progress you need, how do you try to engage with other stakeholders to get the oversight or legislative changes? And with that, I'm excited to have some discussion on this topic.
Okay, thank you very much, Patrick. And I don't see any questions on the chat, but I think there's plenty of material to have an active discussion. I'd like to begin by a question that, has kind of interested me for a long time. And that is the connection between the rules that are part of the Code of Federal Regulations, the guidance, a lot of guidance such as reg guides and other guidance, whether it is interim staff guidance or whatever. And then the third aspect is regulatory practice, and it seems to me there are technical and policy challenges, related to each of these, and they could be quite different. So, I'd like to know if you have given any thought to the distinctions that need to be made so that, there is improved predictability.
Yeah, happy to discuss that. I think one of the things that really starts to come into play there is the idea of what is the, and I hate to use these terms, predictability and flexibility, but what is the essentially predictability of each one of those techniques or those processes, and then what's the flexibility to make changes to it? So I think when we talk about regulation, what is actually in rule, what's in 10 CFR Part 50, 52, 53, those are all very highly structured. It's something where it has to go through a public rulemaking process. It's very well documented. It's very well vetted. And what's in there is the rule. And so ultimately, when an applicant comes back and tries to discuss with the regulator, one of the first things they'll look at is what's the actual regulatory requirements that you're using? What's the justification that you have? And so it provides you a very high level of certainty if something's in the rule. It's not something that staff can just recklessly disregard. But the other challenge is that it's also something that's very hard to adjust. To actually try to make changes to the rules can be incredibly time consuming, incredibly difficult, because you have to re-enter kind of that formal legal rulemaking process to make changes to it. So if you start having lessons learned through operations or through licensing reviews, it could be a bit of a time delay until you can actually make those changes and have it reflected in regulation. The next level down, I think, is when we start talking about the regulatory guides. This, again, is a little bit of a challenging topic. Regulatory guides can be really, really helpful to try to help the NRC staff have some set of essentially consistent set of operating procedures, if you will, for the way they're going to go ahead and evaluate and review different applications for advanced reactors. This can also be really helpful for applicants because they can take a look at that guidance and have an idea of what is staff actually going to be using when they're performing the evaluations. There are a couple of challenges, however, with thinking about regulatory guidance. The first challenge is actually, it drives both ways on it. Sometimes regulatory guidance is something where it is optional. Ultimately, it's not the law, it's not regulation. And so there can be things that are in regulatory guidance that the staff, management, or commission might choose to essentially not use or to change on the fly. And so there can be a bit of an unpredictability kind of in that regulatory guidance process. You can also simultaneously, though, have the other extreme where sometimes, and this is again something that can happen on a case-by-case basis, people can view regulatory guidance as a regulatory requirement and see it as very, very inflexible, when in reality it is supposed to be optional guidance that provides insights on one set of methods to kind of demonstrate compliance, but not the only set of methods. The next kind of set you hit down is regulatory practice. And again, this can be really challenging because it's trying to figure out how do you get consistency kind of throughout your regulatory review. One common concern that we'll hear from some applicants is the idea that sometimes things like your project manager or certain staff performing technical review can lead to an inconsistent level of review. And that can be really, really challenging to try to predict. How do you make sure that for the same set of requirements, you're getting the same set of outcomes, and that you can understand kind of the regulatory predictability? This is also something where you have to remember that licensing predictability goes both ways. If applicants are being timely in responses, are preparing high quality applications, it might be easier for them to kind of move through the process than if they're struggling on their own to actually kind of prepare the documents. So I think it's kind of it's a wide spectrum, and this is kind of one of the ongoing questions we have, is when you think about kind of new regulatory processes, how do you want these to fit in? Do you want the methods or design requirements to be in rule? Do you want them to be in guidance? Or do you want them to be in something even more parallel, that maybe we're thinking about consensus codes and standards, for example, that are kind of brought in either by rule or incorporated by reference? And that can be kind of another pathway forward. You're going to leverage an approved or documented ANS standard, for example. and use that as a way so the regulator goes, yep, that makes sense. They've already done it. We don't have to have a full conversation about it.
Thank you. That was a thorough coverage of the issues. I appreciate that. There's a question from, I think, Bob Youngblood. Do you want to go ahead and read that, Pat? I'm not good at that. Or maybe
I would be happy to. Sure. So Bob's question is, what are the key differences between NIA thinking and the licensing modernization project NEI 1804?
Great. Yeah, so I think the major set of thinking that we've had, and a lot of this has really been informed by our discussions with different advanced reactor applicants that are interested in the space, is that LMP and NEI 1804 are one really good method to essentially license advanced reactors under the existing technology, but they aren't necessarily the only method to license advanced reactors. I think the best characterization you'll probably have of LMP is that it's very much a risk-leading method. It's using probabilistic risk assessment and other techniques to try to help kind of generate insights and kind of lead you through the design process, and then ultimately end up with a design that meets the regulatory requirements. And that can be really effective for many, many developers, and I think it's something that's fairly well documented in the space. One of the challenges, though, is that we've encountered and had conversations with advanced reactor developers who, just due to their design or due to their design philosophy, aren't interested in using that process. They don't want to essentially utilize risk analysis in that way, and want to really think about risk analysis more in kind of a confirmatory or kind of a trailing method. And so the problem is, if we set up a set of regulatory requirements where you're essentially codifying LMP, well, that's going to work really well for some developers, but it might leave other developers out. A really good example of this is that if you have, for example, kind of a small microreactor, you might not want to spend the design effort or the engineer time to actually create a high quality PRA that leads your design that's going to be documented in your licensing materials. So in that case, you might be more interested in thinking about how to use simplified deterministic analyses and accept essentially that higher regulatory margin to get to your outcome. So definitely know a lot of folks that are really interested in LMP. I think it's helped establish a lot of really good precedent, but I think we're really interested in making sure that we end up with a more flexible process. And that's kind of where we see this idea of having LMP as being one of the methods, but not necessarily the only method.
Thank you.
Great. Bob, that answered your question?
Yeah, of course, it provokes more. Like another one I meant to ask was, DOE has been dealing with a spectrum of facilities in their approval process for generations, and I wonder if you see any hope in adapting their ideas to these smaller reactors that you're concerned with.
Yeah, that's a great question. So one of the things that we'll look at are, what are some of the historic methods that were used by DOE? And I think one of the challenges is it's been a while since DOE has licensed a major nuclear facility. If we try to think back to what was the most recent kind of large reactor that was brought online by DOE, it's kind of wondering kind of where that expertise is and what methodologies they're using. And there are, I think it's, oh, sorry, go ahead.
Well, they do little facilities all the time.
Yep. Yeah, and so I think there are probably some insights there. I know there have been some MOUs between DOE and NRC to look at that. But I would have to dig back into kind of what the safety evaluation processes are for DOE. But I think there definitely are some lessons learned there, especially for, you start talking about these smaller microreactors, like ones that they're looking at, specifically NRIC, the National Reactor Innovation Center that they're looking at building out at INL or operating out at INL. A lot of those reactors are going to look very similar to kind of older DOE reactors than some of the major power reactors we have today.
Okay, I think there are two other questions.
Yeah.
Pat, you want to go ahead?
I will. And the next question is from Chip Langdon. And he asked if you can discuss alternatives to topicals to deal with exemptions. He suspects that we'll be facing that on the Natrium design.
Yeah, no, another interesting question. I have to say, unfortunately, for the Natrium design, I think topicals exemptions and topical reports is going to be the way to do it. Just in terms of the idea of trying to lock down regulatory finality on topics. You don't technically have to use a topical report. You could just go through with your license application, submit it, and hope for the best. But I can see as you're kind of finalizing design characteristics, design methodologies, things along those lines, being able to start the conversation earlier during pre-application and then have it finalized when you're moving through the review process is probably going to be high value. I think the interesting thing that we'd be looking at would be for kind of a new regulatory framework for Part 53. How can we create kind of that set of risk-informed and performance-based requirements that really are technology inclusive, so you're not required to do the exemption? Really try to keep the rule as lean as possible, and then allow to have other information in things like guidance or kind of regulatory practice, so you're not required to essentially argue about why this rule isn't applicable, but instead are trying to say how your reactor meets the overall design characteristics.
And Chip, does it answer your question?
Yeah, and like the previous one, it raises more.
That is the challenge of this topic.
LMP, you're really, when you look at LMP, you go in there and read it, and the designer picks this, he picks that, and he justifies it, but that never results in whether or not you know whether or not you're going to get agreement with the regulator.
Yeah, and I think that's something where there's a lot of interest in how these first couple of plants kind of moving through an exemption heavy licensing process are going to go.
Yeah, I suspect it's going to be 3 or 4 iterations before we reach consensus.
Yeah, it's really interesting. It's also going to be curious to see how it differs for essentially the larger power reactors versus smaller reactors. It's been interesting starting to watch the process for Kairos Power as they're working on the licensing of the Hermes reactor, recognizing that's a fairly novel design what they're looking at in terms of the FHR reactor. But as a smaller reactor, are they able to essentially reach consensus more quickly through the research and test reactor licensing process than they would for a large commercial reactor? And how is that going to kind of affect the exemption process?
Okay, great. Well, then we'll go on to Rob Berg's question. And he had said that the NRC is historically inflexible by nature. How are you planning to overcome this?
Oh, I always love a good loaded question. So I think with this one, a lot of it comes down to kind of culture and leadership, at least in the conversations that we've had. I think when you take a look at the NRC as an organization, on paper, everything's fine. It's got a great organizational structure. It's got a great set of requirements. A lot of the stuff makes a lot of sense. And the question really ends up becoming, how can we try to make sure that we've got the regulatory staff, regulatory culture, and then the adequate participation from industry and other stakeholders to ensure that they're providing applications that actually meet the regulatory requirements, and that the commission and the staff is open-minded enough to say, yep, we're willing to kind of take the time and figure out whether or not this meets our high-level safety objectives. I was joking in some other remarks I've been preparing that it almost kind of feels like it's you're tempted to say that you're in kind of the Henry Ford model of regulation. You can license any reactor you want under NRC regulation as long as it's a large light water reactor. And the question is, how do we kind of change the regulatory mindset to say, okay, it's not, does this reactor fit our rules, but how does this reactor operate safely? And then with the idea that safety is kind of ultimately that top level standard of rules that we're interested in. So I think it's got to be culture, it's got to be leadership, it's got to be hiring. I think if we're looking at these, it's no longer going to be just the rote operation and analysis of large light water reactors. You potentially have a huge spectrum of technologies over the course of the next 15 years. And so we're going to need a lot of experts. Yeah, I think if you said how many experts did we have in molten salt corrosion in the NRC 10 or 15 years ago, it's probably a pretty small number. But if we start having some of these advanced reactor developers come through, there are going to be a lot of questions on how you do that. So how do you start to kind of bring in the right talent while instilling the right culture? And that's something NIA and I know a lot of the other NGOs are working through. So that'll be a big question that we're interested in.
Great. Any further questions?
I'm also open to suggestions if people have other thoughts on how we can try to improve culture. I know that's a big issue because they need to make sure they fulfill their regulatory mission at the end of the day.
I would like to just ask another question though. What is the definition for a term that is used by a lot of people, safety case? Can you, have you seen a coherent, description of what should constitute the elements of a safety case, and how that definition can be employed more widely so people can use that approach?
Yeah, definitely. So when we were looking at kind of drafting our kind of proposed, as part of our Part 53 comment development process, I essentially was given the instruction of go write what you think Part 53 should look like, which was an interesting task to get, but I got to do a kind of a scaled down version of it. And part of that was leveraging some best practices that we'd seen from the UK's Office of Nuclear Regulation, ONR, and then the Canadian CNSC, the Canadian Nuclear Safety Commission. And both these organizations, I think, have a little bit more of what they define as kind of a safety case basis. And so with that, I would really say it's more of kind of this performance-based regulatory framework where there are a set of high-level requirements, and then the applicant comes and says, how do we demonstrate performance, or how do we demonstrate compliance with these requirements, as opposed to showing that we meet a set of requirements that will then result in a safe design. So it's really the idea that kind of puts the burden on the applicant to say, this is why our reactor is safe, as opposed to this, our reactor meets these requirements. And if a reactor meets these requirements, then the reactor is safe. So I think it's a little bit of idea of, are you trying to prove that you work with the standard, or are you trying to prove that your reactor is safe? So I would definitely refer you to some of the regulatory documents I know from ONR and CNSC. I think probably have the most concise definition of safety case. And then I think we do a bit of a discussion in one of our more recent NRC, in our November 2021 public comment. We have some discussion of the safety case, but it really gets into all the elements you need to demonstrate compliance. And that can cover everything across the spectrum that you traditionally see in kind of a PSAR or FSAR.
Let's see. Rani has a question.
Yeah, one more question for Ronnie. Do you think a rule with high-level performance objectives and technology-specific standard review plans would work?
Great, thanks for the question, Ronnie. It's like we've talked about this in the past. For anyone that doesn't know, Ronnie Franovich, she works for the Breakthrough Institute, BTI, which is another NGO in this space. It's kind of doing a lot of thought leadership and work on advanced reactor licensing. And I think this is kind of a really interesting way of thinking back to, and if I can just go back a couple of slides, go back to this model. The idea that you have kind of a set of uniform performance requirements. This is something that's constant for all developers. And then to provide kind of a higher level of flexibility or a higher level of predictability, could you have something like regulatory guidance that essentially a technology specific review plan? So the idea is, if you are interested in licensing a high temperature gas reactor, could you work with other high temperature gas reactor developers and the staff to say, this is what we expect to see out of these? And so here's one set of methods that you could use to demonstrate compliance. And that's a way that it allows you to kind of bring in a little bit more of kind of an optional requirement, but again, it doesn't hold you to it. If you think that you can build a safety case or demonstrate the safety of your reactor without using that standard, that would be fine. But this would be one way that you could actually try to get a more predictability out of the process. The way I've heard described to me alternatively is the idea of it's almost kind of like a, and this, I apologize for how silly this is. It's kind of like a build your own omelet bar. The idea is that you have some large set of requirements that you're trying to fulfill, and it's ultimately up to the applicant how they want to meet that. But there are also essentially preset items or preset omelets that you could use that would say, hey, here are things that we know that work well together. And so if you don't want to go through the process of trying to develop your own safety case, use a unique set of arguments, here are things that we know have worked in the past and that the staff is comfortable with. And so it kind of provides that both flexibility and predictability depending on what an applicant actually needs. And that's the idea of kind of opening up this regulatory process.
Great. We do have one more question, and I think we probably have time for this. And this is from Eric Ball. And he said, do you envision quality assurance standards being applied differently for advanced reactors? Is it possible to demonstrate safety without them?
So that's a really good question. I'll be honest, it hasn't been something that we've dug into significantly. I know there are a lot of questions. I mean, I think everyone will agree quality assurance is important. Trying to make sure that the system structures and components that you have actually fulfill their safety function is absolutely critical. I think the question really ends up becoming how you develop and design these programs, and are they reaching kind of their desired outcome? One question I'd had back from my graduate work at MIT was, if we take a look at the essentially the 10 CFR Part 50 Appendix B, the NQA1 safety and the NQA1 safety requirements, do these actually result in significantly safer operation and significantly higher quality processes? And essentially, are you getting your money's worth by using that type of regulation and those types of those types of quality assurance requirements? Or should we be really kind of rethinking kind of what the fundamental idea of how you ensure performance is and how you're relying on things? So I think there are interesting things to talk about with quality assurance when you start talking about trying to make sure that we are meeting our safety functions, but we aren't necessarily putting on excessive regulatory burden. But I do think, yeah, quality assurance requirements are going to be critical for advanced reactors. And I don't have a great answer for you otherwise on how you might try to apply them.
We do have a hand up from Mark Joseph, and I think we've got 3 minutes. Mark?
Yeah. Mark, go ahead.
Yeah, I was just wondering, in my experience with the NRC, you know, they develop their own independent computer codes to look at, you know, core configurations, you know, heat rate, and then, you know, ultimately fuel failure. And so with the new designs, of course, you know, they don't have codes that are developed to independently, you know, review the results of what the submittal identifies. Now, I'm not saying they have to have their own independent code, but I'm just saying that that's the way they've handled things in the past. They don't necessarily just review the code that, you know, that you developed and trust it. They develop their own. So it's, I was just wondering how your concept satisfies that. You know, a lot of times these issues come down to the computer code, you know, the output of the code. So
yeah, I think that's a really good question, especially when we start talking about kind of a wide range of different reactor technologies. How are they working on that? I think you'd probably see the NRC staff leverage a lot of their existing expertise and connections, whether that's in-house codes that they developed or modified, or trying to work with external organizations. So working with the folks at INL or Sandia or other organizations that have some more experience, or hiring external consultants to provide it. But I think you're also hitting on kind of another topic, which is fuel qualification, which is an entirely different and incredibly challenging topic that we're going to have to address. When you talk about how do you actually get the data that you need to demonstrate the safe operation of your fuel under all expected conditions? Well, a lot of times the only way to actually get real fuel performance is to actually test the fuel. And then you end up with a little bit of a chicken and the egg problem of how do you make sure that your reactor fuel is safe before you've ever tested an advanced reactor? And so this gets into really interesting conditions about, or questions about how can we try to accelerate fuel testing? How can we think about surrogate fuel testing? Testing a fuel in research and test reactors to get sufficient data? Or do you try building a safety case where your fuel integrity and your fuel operation isn't necessarily integral to your safety case? And this is one where I think it's kind of thinking a little bit bigger picture about, are there faster ways to license if you are essentially building the way you think about safety in a slightly different way? But yeah, at the end of the day, the NRC is going to have to figure out what they are comfortable with deciding in terms of kind of reaching that conclusion of safety. And yeah, making sure the codes are available is going to be critical to that.
okay,
Let's see, Rani has a hand up, and we'll have to make that as the last question or comment. Rani, go ahead.
Sure, Prasad, and I will be brief. I just wanted to share that with NewScale, the NRC staff asked the applicant to submit executable files and data on the docket so that our colleagues in the Office of Research could run what they deemed confirmatory analyses, but they weren't run using NRC developed codes. They were run using essentially the same executable files and data that were submitted by the applicant. And so it was a bit of a bizarre kind of way for the staff to approach this. And it's a really good question about how they're going to do it in the future and be able to say with some credibility that it's an independent confirmatory analysis. So I just wanted to add that to the discussion to help answer the question.
Great, thank you for that, Ronnie. Yeah, I think the other thing I'll add, and we'll see how this works in the future, is things like the NRC audit process, where maybe the applicant doesn't submit their entire safety analysis on the docket, but potentially could use allow the NRC to actually access their files through a secure server and use that as a way to kind of review the process. But ultimately, yeah, Ronnie's exactly right. It comes back to this idea of what counts for independent confirmatory analysis.
Okay, Patrick, I want to thank you very much for a stimulating discussion and this has been a very successful effort at getting NGOs as a community to help us with, these community of practice sessions. And I do hope that others will come forward. So thank you. And I want to thank everybody who has participated in this, and, wish you all well. Pat, I think
Thank you.
that should be it, right?
Yeah. Yes, and I'd like to echo Prasad, just in saying that this is really a terrific presentation and great discussion. So thank you very much all, and I will go ahead and close it. Bye.
Great. Thank you very much.
Thanks a lot. Bye.